formation of precursors called primordial germ cells, PGCs, in the early embryo to the maintenance of dormant oocytes in the ovary. These endeavors are aimed towards understanding the causes of infertility and birth defects and unlocking the potential of stem cells to generate gametes for research, human reproduction, and agriculture. Most importantly, she's been recently recognized as a recipient of the NIH Director's New Innovator Award, something we're all very proud of.
Thank you, Dr. Bluestone, and thank you to Leader Pelosi for your attention to this issue. So I'm here as a PhD scientist and a junior faculty member at UCSF. I study stem cells, and I tell my kids that stem cells are like superheroes. They're immortal, and they have superpowers. They can be used to build an organ or to repair it. So why should a scientist like me be here talking to you? Because I run a research lab, which is very much like a small business. And my lab is 95% supported by an NIH grant. With these 8% cuts, it will be junior investigators like me who will suffer the most. I don't have a proven track record. So Silicon Valley teaches us that innovation comes from taking risks. And we all know that youthful minds are more primed to take risks. But it's pretty hard to think different when you're spending all of your time raising money. So coincidentally, today is International Women's Day. And I think a time to celebrate the advances in women's access to education. The work in my lab on the stem cells in the embryo that give rise to the eggs of the adult is increasingly relevant to women's lives as women are delaying childbirth more and more. It's well known that every woman has a biological clock. We know that as this clock ticks, the number of her eggs declines and the number of errors in the chromosomes of those eggs goes up. And this leads to birth defects. So recognizing and preventing those birth defects begins by understanding how and when those chromosomal errors occur in the eggs. Additionally, I see the opportunity in my team's research to develop ways to read this biological clock. I envision that one day every woman will be able to go into a drugstore and buy a diagnostic so that she will know how many good eggs that she has left and how many more years of fertility she has left. And I see that this would really empower her to pursue an education, to pursue a career, and to be a mother. We would have more Nancy Pelosi's in the world. The next grant that I write will begin the first steps toward this diagnostic. But if the NIH is going to only fund 6 out of every 100, then don't be looking for this diagnostic on the shelves of your local drugstore anytime soon. So at the time when I trained, it was actually more than 30 out of every 100 NIH grants that were funded. And like most of my colleagues, I trained for over a decade following college. That's 11 years. And thanks to the NIH and the NSF for investing in my training, I got a cherry of a first job at UCSF at the age of 35. The sequestration cuts come in an already difficult environment, and they're going to eliminate many young faculty like me. But really, more importantly, these cuts will drive away the students who are training now, like the people standing behind me now. Those students will see the daunting reality of 94 out of 100 unfunded grants, and they will take their bright young minds someplace else more fertile, away from science and even abroad. The U.S. has been a powerhouse of innovation and discovery in biomedical research, and it stands to lose its competitive edge as a result. Furthermore, the cures and the diagnostics that would come from the long-shot science, those will not be discovered or developed in the U.S. These budget cuts are really like killing our own stem cells. They're slowly going to destroy our potential. Thank you.
To give you some perspective of how much of a star Diana is, the average person coming out of school now is 42 before they get their first semester. So 35, that's incredible. So our last speak today is going to be from Stephen Carr.